G'day viewers, I've finally got this thing hooked up the right way. Active and neutral in. Jump to the complete the other potential coil to get it active out. Active and neutral out on that side. Very noisy meter, so let's put a load in it. Yeah, it stops humming. Spot on the 9. This one there is a spot on the 7 there. Just before the 7, so that should get just before the 8. And this should get on the 0. If it doesn't, I'm running it, then again if it doesn't, I'm only running a 460 volt meter and 230 volts. So it's probably going to run slow, being half the voltage, but I don't know. This is a 2 times 10 amps, so I could run this thing with 20 amps through it, hooked up in this single phase configuration, or 240 volt configuration instead of 460. We're on the low rate. Haven't figured out how to trigger the rate changer. I think you're going to put active and neutral in there, but I've tried it very carefully with a variac and nothing happened, so I'm not sure how that worked. Half the bloody wiring diagram's been scraped off, so it doesn't help when I've scratched half of that off. But she's working. Okay, right. Okay, we're just passing that line now. Yep, seems to be on track, this meter. Oh, there you go, it's running at the right speed so far. Let it get to the 0 and we'll turn everything off and see what the BAZ's at. The load wheel's not warped, that's good. Very noisy little thing, that's for sure. Okay, it's halfway. Yeah, that one there's moved about the same from where I looked at it last. Seems to be pretty accurate, this meter. So 375 revs per kilowatt hour. There's a brake magnet down there. Almost touching the 0. And that one there is almost to that other line. I think this meter might be accurate. Yep, I've got a quarter to go there. And a quarter of distance between the two increments to go there. So they seem to be advancing at the same rate. I hope that rate changer pointer's not jamming up that needle there. I might have to bend it back a bit, but it might get in the way and stop those needles from advancing. And if it doesn't move any more than that, I know it's, that's in the way, that little needle there. Okay, let it get swat onto the 0. Yep, it's almost there. A little increment, I can't see it, it's just about to touch it. And that one there is just about to touch that increment, so that meter's pretty accurate. There you go. Turn everything off. This meter's accurate. Perfect. I'm surprised after all those years, that's good. It means the magnet's still in good nick. The brake magnets have got their full strength. That's moved at the same rate. Has moved a tiny bit more because that's also measuring the potential coils, whatever they're using in this. So you allow for that. And from what I can see, that dial and that dial have advanced exactly 100 watt hours. So this meter's accurate and is hooked up correctly and is running correctly. Perfect. Okay, viewers, let's try another unload. It's wash machine motor. I've mechanically by hand switched this onto the high rate. The needle's not too spot on, but the design it so it doesn't get in the way and obstruct the advancement of the 1/10 dials there. Just plug this little wash machine motor in. Doesn't want to start. Yeah, tired old motor. There you go. So we've got active going in, jump active out, jump into the active to the load, so that's jumped to go out. goes through the potential coil, so they're energised. Then that comes out of the potential coils, back to neutral, neutral in. Potential coils are energised. Then neutral out shares that same terminal block to power point. Active out comes out of here, off the load coil, out through there, jumped it to the other one, then active out. So both potential coils and both load coils for both to the 230 volt lines are hooked up as one 230 volt line. So I've got 230 volts and 230 volts going to the top set of coils and the bottom set of coils. So that the meter runs normally on this this configuration, just normal single phase 240 volt. It's not a polyphase or two-phase meter, it's just a one-phase 3-wire meter. I'll read this, label that again, CNH, and the arrows here. Real directions, not indicated in here or here. They put it here on the nameplate. It's kind of interesting. Meter type, JTR, 2 times 10 amps, 2 times 230 volts, 460 volts total, 50 hertz, one phase, 3-wire. And the maker's number, 3501260, 375 revs per kilowatt hour. Not even warm. And it says property of State Electricity Commission of Victoria, meter number NE for North East Victoria, then 65861. And that's a copper plate, a copper specification plate. That. And there you go. This meter runs accurately. Just got to work out how this rate changer thing works, because what they've done here, the label must have come loose and I just scratched it off. So the way I read this before, I thought neutral just went straight through. Then after I uploaded the last video, I quickly realised this bit here is for your potential coils. Of course all this up here would have told me so, but they've ripped the label off. There's something here, active going into the winding contacts. So something goes active coming from somewhere, from one of these taps here I reckon, comes off there into active, and that must jump from the active in, goes to one of these terminals here. Then neutral for that goes down to here, so that connects to the bottom, and that top one must connect to active in, and a time switch goes in between that. That's from what I can tell what's left of this bloody label here. So there you go, and the date, it's usually down here. P equals 37. I think that's what it says. Very hard to read, it's very small writing and it's perished over the years. So, could be from 1937 this meter. It's possible, so there you go. Yes, this meter successfully passed its accuracy test. So, okay, viewers, that got me thinking. Because this little dial pointer here for the tariff, or high and low rate, that was very sensitive. I just tapped the meter, and that just dropped down to the low rate. I was thinking, why is it doing that? So I moved up to the top of it, and I found there's this little grub screw you adjust. Little clamp here with a screw on it. And you can, this one here, it's got like a leaf spring that holds that whole shaft back hard against its front plate and makes it stiff to move and retains its position. Well, that spring must have gotten tired over the years. And I've managed to undo that little grub screw there and pushed it to squeeze it more. Put more tension on that little leaf spring, which is holding that shaft against this front plate and making it more stiff. Adjusted it and did it up tight, and it seems to be working quite well now. That feels much better. Because I move it and it's sagged back down again. Now it's perfect. Also looking at this little crown gear in here. The camera won't pick it up, but oh, there's a HD camcorder for this, but the only problem, the bloody uploads take a million years. It's not plugged in, so make sure that before you open your meter, always unplug, safety first. That little crown gear I'm pointing to there, you've got a shaft in the middle of it, and a crown gear on one side, one on the other. Basically how that works is a clutch. When this rate changer here, And this little thing here acts as a brake, grabs into the tooth and jams that one out up and stops it. And allows this one to move. That's what that clutch does. One or the other crown gears is allowed to move for this rate. When the low rate's engaged, this one here is jammed, or the brake has been applied, and allows the other little crown gear to move, allowing the bottom one to move. So that's basically how that mechanism works. Very interesting how they've designed it. I've also noticed, looking carefully, the load wheels have a nice pattern on them. It's like an X and a circle, X and a circle. Thought that was quite cool how they did that. A lot of detail. Now she's fully restored. So, thanks for watching.